Let's look at another example. A quality control analyst randomly selects 3 different car ignition systems from a manufacturing process that's just produced 200 systems, 5 that are defective. We want to know, are we dealing with independent events? So these are actually dependent, right? So the answer is no here. And reasoning is the same as before. Once I put an ignition system on a car, I'm not taking it off to put it on a different car. Once it's on there, it's on there. So we are sampling without replacement, which is why they're dependent. So what's the probability that all 3 ignition systems are good? So you're telling us not to treat it as independent. That means we're treating it as dependent. Okay, and what that means is we have to really be careful because this is conditional probability, because this is dependent on what's happening here. So given I select a good one here, what's the probability this one's going to be good? 200 systems, 5 are defective. If 5 are defective out of 200 total, then there are 195 that are not defective. Okay, and we're calling those good. They're good systems. So the probability the first one's good is 195 out of the 200. Okay, the probability the second one's good. Okay, remember, it's conditional, all right? So given that this is good, what's the probability the second one's going to be good? Well, we now have 199 systems because we've used one. We put one on a car, and we assume we put a good one on the car, so we have 194 that are good. And then what's this probability? Well, this is dependent on what happened here. So we're asking what's the probability that this one's good, given that the previous 2 was good. So this would be 198, because now we have 198 ignition systems left. And out of those, 193 of those are good, because we put 2 good ones on 2 cars already. Or at least that's what we assume. If we type this into the calculator, we get 0.9265. So there's the probability that that's going to happen. Now, we can actually use that 5% guideline rule. Now, this is not cumbersome. It was not difficult to come up with this at all. So the exact answer is always the best answer. This would be your best answer here. But just to show you what would happen and how close these answers would be, let's use that 5% guideline. So let's treat them as independent. First off, do you have less than 5% of the population here? Where we're selecting 3 out of the 200. And 3 divided by 200 is 0.015. And that is less than 5% of the population. You're looking at 1.5%. So it is something that we can consider, 5% guideline rule. And what that says is we're going to treat them as independent. So that first probability would be 195 out of 200. That second probability would be 195 out of 200, because we're pretending we're doing this with replacement, which is the same thing as 195 out of 200 raised to the 3rd power, because I'm multiplying it by itself 3 times. And that would give me 0.9269. So you can see how these answers are going to be close. They're always going to be close, but this is an approximation, right? Because we pretended that they were independent when in fact they were actually dependent. And this is the exact. So the 5% guideline works if you just need a quick estimate. But it doesn't work if you need the exact. Okay, but if it's cumbersome, definitely use it. And then the last one. We have 2 cards that are to be randomly selected without replacement from a shuffled deck. We want to find the probability of getting an ace on the first card and a spade on the second card. So notice we're doing this without replacement. That's important. We want the probability of an ace and then a spade. Okay. Notice these are not mutually exclusive. Okay, we could pick one card that is an ace and a spade. So we actually need to take what's going on here and we need to reconsider and rewrite this. So what are the possible scenarios here? Well, we could have picked first the ace of spades. And then we could pick a spade. Okay, that's scenario one. That's using that idea that's not mutually exclusive. Or we could pick some ace that's not a spade. There's 3 of those in the deck. And then pick a spade. So to figure this probability out, we're going to have to find each one of those using the multiplication rule and then add those together. So let's go with that first scenario. So the probability is ace of spades and then a spade. So ace of spades in the deck, there's 1 of them out of 52. This is a multiplication rule because I am finding the probability this happens, and then I'm choosing another card, so I'm choosing 2 cards here. So we're doing it without replacement. So if I find this probability, I assume success. I assume I chose the ace of spades. I now have 51 cards in the deck. And remember, originally we had 13 spades. Now we're down to 12 because this guy was a spade. So our probability there is going to be 1/52nd times 12/51st. And that's going to give us a 12 out of 26/52. So now let's look at that scenario, that second scenario. So there's scenario 1. Scenario 2 is when we look at the probability that some other ace happens. So we choose an ace that's not a spade, so a heart, diamond, or club, and then choose a spade. Okay, well, that first card, there's 3 aces that's not a spade out of the 52 that's available. Now I'm down to 51 cards that are available. Okay, I chose something that's not a spade here. How many spades are in my deck? I have 13 spades in my deck. So if I multiply this together, it's going to be 39 out of 26/52. So I've taken this event that's complicated, picking an ace and then a spade, thinking about it in terms of mutually exclusive events, breaking it down into 2 scenarios. So the probability here is of an ace and then a spade is equal to the probability that we choose the ace of spades and then a spade. That was scenario 1 plus the probability of scenario 2, which is ace that's not a spade and then a spade. So we have rewritten that complex event into 2 simpler events. And then all we have to do is add those together. So that's going to be 51 out of 26/52, which is about 0.0192. So that probability ends up being a little less than 2%. So that's the end of the multiplication rule and addition rules. In the next video, we're going to look at conditional probability a little bit more. See you then.